Today we are going to talk about three basic trigonometric ratios. And these are our three basic. You've probably seen the buttons for these on your calculator, but this is what we call trigonometry, and they are the sine, cosine, and tangent. Now we use abbreviations. This is the sine, okay? It is spelled this way, but we're going to write it with an abbreviation, and the button looks like sin. Please do not call it the sin of x. It's the sine of x. You call it the sin of x, you are sinning. You're breaking the rules in mathematics and you're not pronouncing things correctly. So please call it the sine. We have the cosine, which is abbreviated COS of x, and the tangent of x. And these are ratios, which means they are fractions. Okay. Let me write the abbreviation for tangent. Tangent. Okay, we're going to say the whole word. We write it as an abbreviation. Okay? So if I have a triangle here, let's make a better triangle than that. These apply to right triangles only. Right triangles only. So you need the symbol on the side. I'm going to call this angle X, or you're going to start seeing it referred to with this Greek letter here, theta. Theta doesn't mean anything different than X. It just means it's an unknown, but we use it for angles, okay? This is the Greek letter. It's a capital letter, and it's theta. It's a circle with a little squiggly line through it. Okay. There are key names here for the sides. So we have two legs of a triangle. The hypotenuse is always the long one. It's across from the right angle. Okay? The leg that is adjacent is the one that is touching the angle, or it's part of the angle, really. Okay? So if this is my angle here, X, this is the adjacent side. This here is called the opposite. Okay? I'm going to make another right triangle here below. This time, if my angle is theta, this side across from it is opposite. The hypotenuse is still the hypotenuse. Okay, and this side is opposite. Looks like I spelled hypotenuse wrong above, so let me fix that in a second. Might be UES, I can't remember. The sine of x is a ratio, opposite over hypotenuse. Okay, can abbreviate opposite with O, adjacent with A, and hypotenuse with H. And I'll give you an example with some numbers in just a second. The cosine of x is a ratio that is equal to adjacent over hypotenuse, and the tangent of x is equal to opposite over adjacent. Okay? We have a little memory technique for this because while I'll let you use notes on your test, you're going to take map tests and STAR tests and in a couple of years the SAT, and they don't let you use notes. And you probably won't have done this for several months. So we want to remember this as SOHCAHTOA. And I call them the three crazy Greek guys. So, and I call them the Greek guys because the Greeks were the ones that discovered and defined these ratios. So stands for sine equals opposite over hypotenuse. cos stands for cosine equals adjacent over hypotenuse. And it must be equals. And tau stands for tangent equals opposite over adjacent. Okay. So I'm going to give you some triangles and we're going to write the ratios. I can only write trig ratios if it's a right triangle. So in this case, sine of theta, the side opposite theta is 3 over 5. So if it says write the sine ratio, you just say 3 over 5, leave it as a fraction. It says write the cosine ratio. The adjacent side is 4. Hypotenuse is still 5. It says write the tangent ratio. Opposite 3 over 4. It says give the 3 trigonometric ratios. You write this for that particular triangle. Let's make another triangle. I'm doing ones with nice numbers. These are what we call Pythagorean triples because the Pythagorean theorem tells me they're all whole numbers. So the sine, if we're going to call my angle up here, we're going to call it x this time. Sine of x equals opposite 24 over 25. The cosine of x equals adjacent 7 over hypotenuse 25. The tangent of x, tangent is opposite over adjacent. Opposite of x is 24. Adjacent to x is 7. And that is my trig ratios.